All right, let's talk about the derivative or the instantaneous rate of change or the slope of the tangent line. So let's say that I want to find the derivative, or either of these things, this also means the same thing, at a specific point, x equals 3, of this function. One way we have to find that instantaneous rate of change is to find the limit as x approaches the specific value c of our change in f of x, so f of x minus f of c over our change in x, or x minus c. So this is our average rate of change formula, but with the limit as x is approaching c, so that we're getting to the instantaneous rate of change where we're approaching one single value rather than two different values. So let's talk about how we could use this to find this derivative or this slope of the tangent line. I would say the limit as x is approaching my specific value, which in this case, this is my c, 3, of f of x, which is just my function, 2x squared plus 3, minus f of c. So in this case, f of c would be f of 3. So I could find that by plugging in 3 to my function. 2 times 3 squared plus 3 would be 9 times 2 is 18. Plus 3 would give me 21. So I'm going to subtract 21 all over x minus my c value, which is 3. Very good. So now I'm going to just simplify things a little bit. So I'm going to go ahead and combine like terms on the top. 2x squared. If I do 3 minus 21, that would give me a negative 18 over x minus 3. And I notice that I can factor out a 2 here. So I'm going to pull out a 2 just to make my numbers a little bit easier. And I'm going to have x squared minus 9 over x minus 3. If at any point I think about, okay, taking this derivative and trying direct substitution, I'm glancing at this and I'm noticing that I'm still going to get 0 on the bottom. So I'm going to have an indeterminate form. So that's why I'm trying to simplify the top here. And anytime we have an indeterminate form, one of the things to try is factoring. So let's go ahead and try to factor the top, and I notice this is a difference of squares, so that'll give me x minus 3 times x plus 3, and perfect, I've got an x minus 3 shared on the top and the bottom, so I can cancel out that common factor, and that leaves me with the limit as x approaches 3 of 2 times x plus 3, and now I'm ready to do direct substitution, and I'll have 2 times 3 plus 3, or 2 times 6, which gives me a slope of 12. So f prime of 3, or the derivative of the function at 3, would be equal to 12.